This is 5.5 Systems of Inequalities. So let me remind you, before we get to a system of inequalities, let me remind you of a few things about graphing just plain inequalities. So here I have y equals x squared, and I just graphed a parabola. But notice this is y is greater or equal to x squared. The parabola is graphed the same way, but notice it's greater than that. Y is greater than x squared. And the highlight inside, it literally represents, think of it this way. So let me come back over here. So think of it this way. Here's y equals x squared, and I want all of the values that's going to make this statement true. So here's what the book recommends, I recommend, is you test a point. So like literally you test a point, like pick some random point. It says greater than, so maybe it's going to be above it. So you pick a random point, like this is the point 0.5. And if you put 0.05, if you put 0.5 into the x and into the y, see, that's a true statement. Well, so test another point, test another point, test another point. So if you start testing all of these points inside, you're going to have so many points, it's going to eventually make it solid. And that's why we highlight inside, because it literally it represents every single point inside of there will be true. If you tested a point outside of this thing, like 5.3, that point would not work. So 5 squared is greater than 3, which is false. Or 3 is greater or equal to 25. That's a false statement. So something out here does not work, whereas something inside of that does. So the highlight represents, just an infinite amount of points. And you literally just have to, just kind of color it in or shade it in, representing all of the infinite amount of points that goes inside of there. All right, so let's look at a couple other scenarios. So here I have y is less than x squared. Notice it's still the same parabola. I also want to point out that it's just less than, so it's not a solid line. Now specifically, if you go back to here, you could, because it's greater or equal to, a point on the line actually works because it's greater or equal to. So specifically on this one right here, less than x squared. So all of the points that's on the outside of this, if you take some random point out here, all of these points outside of the line, less than, then it would literally work. Whereas if you tested a point inside of here, it would not work. So let's look at the scenario of a circle. So if you remember the generic formula of a circle, so you have x minus h squared plus y minus k squared equals r squared. So you graph the circle, radius 5. So that's the big clue, radius 5. And so I drew my circle, and it says less than or equal to. So less than that line. And so you test a point. If you're not sure which one, do I shade on the outside of the circle? Do I shade inside of the circle? Just pick a random point inside of the circle and see if it works. Or pick a random point on the outside of the circle and see if it works. And then you can tell, if it's, you shade on the inside or the outside. And again, it represents an infinite amount of points inside of that circle. And then also notice it's a solid line because of the equal sign. All right, so now let's actually switch gears and let's try a system of equations. So notice we have a circle here, so you should recognize that it's a circle, and this is a line. So we have a circle, and we have a line. And so when you graph each one of these, we're going to pay attention to, this is just a plain less than. So that's going to be a circle, a dotted circle with radius 5. So we're literally going to draw a circle radius 5, and then we're going to go ahead and graph the other line. If you put this into y equals mx plus b, all right, so if we put it in y equals mx plus b and then graph it, we're going to get a certain diagram for each one of those. So notice one, if you take it step by step, notice I drew the circle, radius 5, notice it's a dotted line, and then it says less than. So if you just focus on just the circle, less than, notice it, first of all, it's a dotted line, and then notice that it's less than, so that means I'm going to be shading on the inside of the circle. So if I shade on the inside of the circle, so it's every point inside of that circle. So that's one way to look at it. We can just shade everything on the inside of that circle. And then if you graph the other line, you can focus on what that's going to look like. So I went ahead and graphed the, we'll call that the blue one. So I graphed the blue line. And notice what this says, it's greater than that line. So if you just focus on just the line, okay, and if we want to do greater than that, and if some of us can just see which side of the line is greater. If not, you just simply test a point, and you'll see that this side of the line will work, okay? These points over here will work. So that means everything on this side will work of the line, okay? Everything on that side of the thing will work. And everything on the, so in other words, let me shade this, and I'll do it in green. So everything, and again, I'm doing this in parts. So if I shade everything on this side of the line, okay, so everything is shaded on that side. And then, but notice the circle is shaded inside of the circle. And because it's a system of equations, system of inequalities, what I want is I want all of the points that will work for both of them. So notice what the color yellow and green cross, and that literally crosses, what's the intersection between all of those crosses inside of here, just inside of here. So what I'm coloring in, what this represents is all of the points that will work for both of them. And you can pick a random point inside of there just to check it. So if you check 2, 3, or even 2, 2, if you check 2, 2 inside of, put 2 and 2 there, put 2 and 2 there, and see if it works on both inequalities, it will. If you tested a point over here, it would work for the blue equation, but it would not work for the yellow, the red circle. So if you tested a point right here, it would work for the yellow, but it would not work for the blue line. If you tested a point over here, it wouldn't work for either one of them. So you're trying to find the points that would work for both systems of equations, and every point inside of here would work. And so that's literally, there's an infinite amount of points inside of that section right there. So let's try even a bigger system of inequalities. So here we have 4 different scenarios, 4 different inequalities, and we're going to graph each one of those, and then notice what area is in common. So notice all of these are actually lines, which makes it very nice. So just in general, here's the general idea. We're going to graph a line, we're going to graph a line, we're going to graph a line, and we're going to graph a line. Something like that. We're going to graph some line, 4 lines, and it's going to cross. And notice how many different sections there could be. All right. So literally, we could have section. Again, this is a bad illustration over here, but I could have that section colored, this section, 4, 5, 6, 7. So each one of these sections, one of those sections is going to be colored because I need to find which one of those sections, let's say it's 11. So these points inside of 11, all of these points will work for all 4 of these lines. And that's the general idea of what I'm doing here. So let's look at, let's graph each one of these. I did color code them so it's easy to see. And we're going to we're going to shade each one of these after we graph them. So let's first graph each one of those. And again, what helps a lot of us is if we solve for y equals mx plus b. You don't have to do it this way, but if we solve for y equals mx plus b on this one, this would be negative 1/3 x plus 4. If we took the red one, if we solve for y equals mx plus b, this would be less than or equal to negative x plus 8. And these two, the blue and the green, they're already as simplified as they can be. So, by the way, one other thing, notice they're all equal to, so they're all solid lines. If one of these, like let's say the blue one was a dotted line, if that was just a plain greater than, that would be a dotted line. So you've got to be careful and pay attention to all the small details about that. So let's go ahead and graph each one of those. All right, so I went ahead and graphed each of the lines. And I also, you don't have to do this obviously, but what I did is I kind of drew a scrap model over here, and I labeled the sections 1 through 11. And again, you don't have to do that, but as far as teaching you, I want to show you that there's actually 11 possible sections that, and only one of those is going to be shaded. So what I would do is try to, there's several ways to do it. I mean, the book recommends that you literally just test a point. You pick a random point and you in one of those sections and see if it works for each one of those. You know, and then you could rule out each section. You could do that if you want. That's not a wrong idea. I would suggest you just look at it in a different manner. So I would suggest starting at the bottom where it says y is greater than 0. So y is greater than 0. So that's the green line. And notice it says greater than 0. So literally it has to be above that line. Has to be above that line because it's greater than 0. So in other words, it cannot be section 11, cannot be section 10, cannot be section 9, cannot be section 8. All right, it cannot be those. Just by looking at that one alone, I've ruled out 4 sections. Now let's look at the blue one. The blue one says x is greater or equal to 0. That's the blue line right here. And it says x is greater than that. So everything greater, so I'm going toward the right of that. So that rules out section 1, 4, and 5. So that it has to be rather section 2, 3, 6, or 7. And I've narrowed it down just by looking at that. So let's look at the red line. So the red line, I'm just going literally, I started off with the bottom ones because I think those rule out. Basically, this tells me that it's first quadrant. That's really what it tells me. Those two immediately tell me the first quadrant graph is what I need to look at. So let's look at this one. So here's the red line, and it says less than or equal to. So here's the red line, and it says less than that line. So again, we want to go less than that, which is lower than that. So again, if you're not sure which way is less than, rather you're not sure if it's a point over here or a point over here, then you can easily just test a point to be able to do that to see which side is. But less than means it's going to be on the left side of that, and so that rules out section 2, okay? And it rules out section 7 because it has to be less than that. So now I know it's in between section 3 and 6. So in other words, it has to be this or this. I've narrowed it down to those two. And then finally, this last section, I've graphed this line right here, and it says less than that. So literally lower than that line. And so I'm literally going to be shading in section 6. So this right here is the correct section. And again, let me remind you what that means. That means every point inside of this, every single point, there's an infinite amount of points inside of here, will work on every single one of those. And you can easily test it. So let's just test one point just to show you it will work. So if I go to 3, 1, so I'm going to test the point 3, 1. So the y is greater than 0. Yes, it is. Check. The x is greater or equal to 0. Yes, it is. Check. So you literally just check them. So I'm plugging in 3, 1. So if I put 3, 1 right here, is that less than or equal to 8? Check. If I put 3, 1 inside of there, is it less than or equal to 12? Yes, it is. Check. It works on all 4 inequalities. So that's a good way to check it, just to double check it, make sure the shaded area is the correct way. Just test a point inside of there. And that's the system of inequalities.